Yeah. Hello, everyone. Thank you all who joined today. We'll get started right away. So today we're going to be making our model. Before then, whoever didn't present yesterday, raise your hand if you didn't present yesterday or just type it in chat. Okay? I just want to get a head count so we can finish off presentation. Okay, Karthik didn't. Okay, who else? Who else? I know a lot of people here haven't presented yet. Okay, my group didn't. Okay, good. Wasn't here Wednesday and Thursday. Should I be worrying about presentation? Mm, no, it's okay. Wednesday and Thursday. Let's see what we whatever. No, I don't think there's that much of an issue. Okay, since you weren't here, we'll do a quick review on decision trees before I get into the code. That's fine. All right, cool. Sanjana, do you have the code for your project?
I
Who has
don't
the
have
code?
the code.
Someone else does? Do you know who it is?
I don't think he's here in the meeting.
If you know him, can you just text him on the Discord and ask him to join or to give the code? Um, yeah.
Um, I'll see.
Okay, cool. Karthik, do you have the code? I'm pretty sure you do, right? I saw you were working
Yeah,
on it.
I do.
Okay, cool. All right, go ahead and present.
How? Like share my screen?
Yeah, go ahead. Wait, do you have permission? I think I gave permission, right? Or no? Try sharing your screen.
Okay. Uh, should I like run the project?
Yeah, hold on, it's loading. Yeah, you don't need to run it. Just show me your output. It's the screen is loading, so I can't see it yet. Yeah, okay, good. Let's see your error. Do you have an error on yours?
Yeah.
Can you go down? Okay, keep going down. Just
Down.
keep going down until I say stop. Wait, you're going up. Oh, okay, yeah, good. Okay, yeah, keep going down, all the way down. Okay. Yeah, you're good. Yeah, just try running it right now. It might take some time, but just try run. Yeah, you can do that, I guess. Okay.
Uh, Nothing showed up. Oh wait, nothing showed up. It's just like a big error message.
Oh, yeah, that error, that's you can just delete that first code. You don't really need that actually.
This?
Um, so you can just delete that. So you don't need that.
Okay.
Yeah, go ahead and delete it. And then just run this up. Just click that play button on the top. It's like, or you can just do run. It's fine. It doesn't really matter. Okay, file not found. Let's see. On cancer. Oh yeah. Why? Okay, I know why. Click on cancer. That's CSV. Okay. Remember how you did show in file browser? Remember you right clicked on the project file? Go ahead and right
Oh
click on your project file.
wait, it
Not
won't
there.
show up.
Not there. Not there. Here. Right here.
Okay. Wait, what? Like,
Not like right click here and then it should tell you something. Did you right click or double use
I
your
did.
two fingers? Yeah. And then click show in file browser.
Okay. There.
Okay. Go up to your code. Cancer. Did you misspell cancer or something? Cancer.
I don't think so.
CSV. It's weird. That's strange. Okay, go create a new cell. Just click that this plus. No. Just click this here, right here.
Plus.
No, not there, not there. Like exit out of that. Like click here. I'm like annotating on your screen.
Oh yeah.
Click that. Okay, now click on this plus here. Yeah. Okay. Did it create? Now go scroll down on your code all the way down so you don't see there anymore. Just keep going. Yeah, okay. Now type in PWD
PWD.
and then do shift enter or click on this play button. Yeah, let's see where you're at. What? Your thing is it's kind of interesting. That is interesting. Okay, that's fine. I think it might be because your workstation's not set up correctly. I can help you after class. Your code is correct though. So just go back up and then just explain your code. That's fine.
Explain it.
Okay.
Well, I had
Start from your imports. Tell me what each import means.
uh from like the top import.
Yeah.
Uh,
Go ahead and tell me what the things in green mean.
uh
Yeah.
I think importing pandas is PD means like
So what does pandas do? Where are you using pandas in the code? You're importing as PD, right? So hint right here. What does it do then? What
I
does your
think
code do on that line here?
variable. Can you read CSV?
PD.read CSV. Okay, I'll help you out a little bit here. Okay, so import pandas, what it does is it's importing in a library, right? Because we don't have, you don't want to write all the code yourself, right? If there's already something done, you don't want to reinvent the wheel,
Yeah.
right? So there's already a library we can use that can read through the CSV that we give it. Okay, so we're giving it the CSV lungcancer.csv, right? And what this does, it stores, in a variable, like I taught in our first class,
Mhm.
the CSV. So it's reading it. So now the code has access to what? Your CSV. Okay. That's all Pandas does. It's like read your CSV down. Okay. So next. What does this do here? This code.
Wait, which code?
I'm underlining it. Feature columns, that code.
Ah, uh,
This line here, right here.
yeah, I can see. I think it's like making like columns that like one column is age, tumor size, blood marker, family, smoker, and X is data.
Mm, Okay. So what you're doing here is remember data. Data is what? PD.read CSV. Okay.
Yeah.
And it's taking your data, that CSV file. And if you go back to your CSV actual file, if you click on that, you'll see that the names, your columns are what? Age, tumor size, right? You're setting the that variable, which is your independent variable, right? You're setting it as these columns here, right? That's what you're setting in your code. You're doing X data equals data, and then you do double brackets to tell it it's an independent X variable, right? In your code. That's what this thing is here, okay? And
Okay.
then your Y data, you're getting your dependent variable and you're using logistic regression, right? So your dependent variable is what? 0 and 1. That's what the values are. So your independent variable in this case is cancer diagnostics, whether you have the cancer or not. And your independent variables are age. You're seeing what has an effect. Okay, so you're putting in the data for this. And then this part of this, you're just doing a train test split. Okay. This is very necessary for larger databases. Go scroll to the right. I want to see what your train test split is. Okay, yeah. So you have a train test split of 80-20. So that means that the data is using 80% for training and 20% to testing. So remember in our first class, I talked about new data in the testing phase. Yeah, that new data is coming from the 20% it hasn't seen. So it creates the separate data set through this line of code here. Okay. And then, okay, after this, you got it. All right. So go to the left and explain to me the next part of the code.
Okay. The initialize logistic regression model.
So what does this do here? What are you creating? Are you creating something, assigning something, doing something with it? What are you doing here?
I think I'm. One sec.
It's okay if you don't know. So you're just creating your logistic regression model. So you imported a library. Remember all the equations I've taught? It does it all here. So you created your model to use, and then in your next piece of code, what does it do? What do we
This
do
is
here?
training the model. Like.
Yeah, good. Yeah, training model, good. So this is where our loss function comes in and our gradient function for optimization comes in. Probably they're not using gradient. That was just an example of an optimization framework, but they probably have their own optimization here. Okay, good. Next.
This last line, it's saying like predict the test data. So I think it's like the line of best fit.
Yeah, but you're using logistic, so you're using your sigmoid function here instead. Line of best fit is for linear regression, right? So good, good. You understand the basics of it. And then the rest is just, you're printing out your results. That's it. Okay, good job. You can stop sharing. That's fine. Okay. All right. So before we get started on the code, we'll just do a quick recap of what we did yesterday. So give me 1 second. Share my screen. Okay, yeah. So yesterday we actually did day 5 because there wasn't enough people presenting. So that is fine. Today we'll just go over it quickly for those who weren't there. Um, okay. Can you guys see the screen? Can I see a thumbs up or something? Okay. Good. Good. All right. So let me just okay, this is kind of a complex topic, so it's good to always do a refresher on it. Okay, let's work with decision trees. Okay, decision trees are something that we've never seen before in our previous, days. It's something kind of new. There's a lot of complicated things going on. It's not like one single thing, right? There's multiple frameworks for the decision trees. So let's explain a basics on what decision tree is, right? So a decision tree, we have our branch, which is this blue area, and our two leaves, okay? Um, what it does is we have a statement, it's a question, and the model makes a prediction based on what the answer to that question is. So, for example, in this example, a student would like to learn about artificial intelligence. If that is true, he takes my workshop. If that is false, he plays Roblox or does anything else, right? So it's making a prediction, and the prediction here now is he takes this workshop. Okay. Um. Okay. Okay. So there's two types of decision trees. There's classification and regression trees. We worked with a lot of regression, right? Linear, logistic regression. Classification trees are basically just making a prediction, but in regression trees, you're specifically making a prediction based on a numeric value. So in this case, a normal 17-year-old goes on a diet. If that's true, he weighs between 120 to 130 pounds. That's false. He's 150 pounds. Okay, so that's how regression trees would work. And let's use this data set. Actually, we can move on. Yeah. Let's start here. Okay, let's build a decision tree using this method called Gini impurity. So Gini impurity method, there's a lot of different methods for decision trees like entropy, Gini impurity, and there's many more. But I would say Gini impurity is a very good basic method to start with, and it's one of the most popular methods. So let's start with Gini impurity method, okay? So let's start this. So let's use this data set as an example. So we have attends class, homework, study hours, and passes or not. If you notice, passes and attends class, homework are what? Categorical data, right? It's not numeric data. Okay. And then we have study hours as numeric data, and it's not continuous, it's discrete, right? We're not going to decimals, things like that. It's discrete. Okay. So this is how our final tree would look like, okay? We have attends class, true, false, study, greater than equal to 10, true, false. Okay, so this is not how our tree looks like. This is how a perfect model of a tree would look like, and it'll make a prediction based on it. For example, you have a data set, okay? The student attends class, okay, that's true. So it goes down to this. Now it checks, did the student study more than 10 hours? If that is true, it makes a prediction on their next exam. They're going to pass their next exam. And that's false, it does not pass. So let's figure out, how does our model create this tree? Like, does it just randomly come up with different things, asking questions? Is there an optimum strategy? Is it just random? Well, no, there's actually an equation you'll use. And there's a whole entire process in how this works, okay? So let's say we've never seen this tree before, okay? We need to first know what our first question is. Okay, how can we do that? What is our first question? Is it attends class, homework, study hours? We gotta know, right? So let's start with attends class, okay? So let's see how it works. Let's make a simple tree to figure this out. So we're creating a decision tree here. We're saying attends class. Okay, we check. Okay, attends class is yes. Does he pass? Yes. So we count this one. Okay, so here we'll now change this to 1. Attends class, no. And does he pass? No. Okay, so now we have 1, 1. Okay, 1 pass, 1 fail. Attends class, yes. Actually, sorry. Attends class, no. Actually, this would now go to the false. So now this would be 1 here. So it'd be 1 here because it's false. Attends class, yes. Okay. Does he pass? No. In this case, he does not pass. Okay. So we have 1 yes, 1 no for this blue leaf here. And finally, we have another yes, and then it's passes. So now it's 2, 1. Do you see how I'm collecting this data? Okay. And we're just creating a quick little table. All right. And now let's do the same thing for homework. Okay. Now we have both of these. Since both of these are the same, we're just going to use different values for this example so you can really understand how this works, okay? So we just made up some random values for example purposes. So how can we now quantify the differences and find what to use, right? Now the ultimate goal is to what, right? Figure out what the top question is. So how can whatever we just created help us with that? So how that works is we check its impurity. Okay. So if you notice, this leaf here and this leaf here is pure. Why? Because it has one solid data set, right? It has all data set at no or yes. It's not like one in no and then three in yes, or three in no and one in yes, it's solid, right? We have zero in yes in this case and one in no. In this case, three in yes and zero in no, right? So it's pure leaves. So now we got to check the impurity of the entire thing. And what we do in the end, after checking the impurity of the entire branches, the questions, we now see which branch has the lowest impurity. And that would be our first question, because that will filter our data set much more. The more pure a leaf is or a branch is, the better it is a stronger question to ask, because it filters everything down much quicker than if it was an impure branch. Okay? So whatever I said right now might sound very confusing, right? But let's break it down even further to understand what this really means, and we can break it down, okay? So we're going to use the Gini impurity method. Let's start with this left leaf here, okay? We're going to use this equation down below, 1 minus summation of p squared. So that's just probability squared. All right. It looks complicated. It's really not. Remember, if summation is just, you're creating addition. It's just adding up. So for example, we have like 3 leaves. We'll just create the probability of those 3 leaves, right? We'll do leaf 1 plus leaf 2 plus leaf 3. That's all the summation is. You're just doing it for how many leaves there is. Okay. Nothing too complex there. It looks complicated math-wise, but it's really not. Okay. So let's start with this left leaf. So we do 1 minus the probability of yes squared minus the probability of no. Okay. So how would this look like? So we get 1 divided by probability. If you guys know how to solve for probability, all it really is, if we're looking for probability yes, we have 3 yeses, and then we divide it by the total. So 3 plus 0, 3 plus 0. Well, that's just 3. That just cancels out to what? 1. Okay, so 1 squared, we get 1. And then the probability no, 0 divided by 3, that's 0. 0 squared, 0. So since it's a pure leaf, we get a Gini impurity of 0. So you can just, double check that through the calculation. But since this is pure, you're obviously going to know this is going to be 0, because there's no impurity at all. So there's no need for it, right? Now we did the same thing, the same equation steps for this right leaf. We're just doing 1 minus the probability yes plus no. Okay, probability no squared. Both of them squared. Okay, so we do the same thing, and now we get 0.48. Okay, so let's do that. Now we want to figure out. So we have 2 types of Gini impurities, right? It's not the same for both leaves. So how can we set a Gini impurity value for this entire question or branch? How can we do that? Why do we add 0? Why do we add 0? Okay, so why do we add 0? Good question. Let's go back to this calculation. Right here, 3 divided by 3 is what? 1 squared, minus 0 divided by 3 plus 0. Oh, are you asking why we add 0 here? Well, a probability is the total, right? So the total, it's like whatever you're comparing it with. In this case, let's say yes. So 3 divided by 3 plus 0, because that's the total. In this case, it would be 2 divided by 2 plus 3, or 2/5. Does that make sense? I wasn't sure what you're asking your question on, but I'm assuming that's what it is. Dia, is that your question? Did I answer it? Okay. Yeah, you can put that in chat, but Ritvik, just wait for a bit. I'll explain the next part and then you can put it. Okay, so yeah, okay, sorry. Okay, so now we need to figure out how we can get the total Gini impurity for this entire branch, since they're both, well, different, right? So what we can do is we can get the weighted average. So everyone knows how to get average, right? We just do 3. So we can start with this left branch. We can get the total of this branch and add it with the total of the entire thing. So it would be 3 plus 3 plus 5 because 3, 2, 3, right? So 3 plus 2 plus 3, it's just 3 plus 5, right? So you got 3/8. And this for this right branch, we have to get the total of this branch, or this leaf, sorry. 2 plus 3 is 5. Okay, that's how we're getting 5 here. And then we do 3 plus 5. We're getting the total of both leaves. So that gets us our weighted average of both leaves. Now, using this weighted average, we now multiply it by that leaf's Gini impurity. Left leaf was 0, so anything times 0 is 0, right? And then this right leaf is 5/8 times 0.48. So we get 0.3. And then finally, we add the total. We add 0 plus 0.3, and then we get the total Gini impurity. Okay, so you can remember this by a simple equation. Total equals the summation of weight times Gini impurity. And then you just add up the total. Okay? Simple equation. And now we just do the same thing for both. So I didn't want you guys to be bored with me doing the same thing over and over again. So we just did the same thing and got these two values here. Okay? And now we need to do hours. But what's different about ours? Who can point that out real quick? Who can point out what's different about ours?
Discrete values.
Good. Yeah, it's numeric discrete values. Okay, good job. So we can't do the same thing, right? Because how are we going to group it? How are we going to group it by how many 3s there are, how many 15s there are? Well, there's just one in each one. We can't like group it, right? It's not categorical. So what we can do is first, we're going to sort this list. We're going to sort it by least to greatest numerically, okay? So after we sort this list, what we do is we calculate the average for each adjacent value. What that means is we do 3 plus 6 divided by 2, 2.5. It's getting that middle number. 6 plus 10 divided by 2, 8. 10 plus 15 divided by 2, 12.5. Okay, we get these for each adjacent value in the data set. So since there's 4 data, we're getting 3 of them. Okay. And now what we do with these is now we're creating our own branch. We're saying study hours is less than 4.5, right? Our value, there's only one data. So we can use this true value here. So 3. Does it pass? No. In this case, no. And then we have 6, 10, 15 to check. It doesn't pass one time and then passes twice. So then we create this. Okay. Now we do the same steps over and over because we created what? We created our branch, right? We created a branch with these values here. So we just do the same thing. We calculate the Gini impurity, get the total Gini impurity doing the same method, and then we just do it for all of them. Okay, so this is just an example data. I actually made up these two values here just for demonstration purposes. So if you notice here, now this is the lowest value, right? So now this stays as our final question. Study hours is greater than 8. That's going to stay as our final question. We're keeping that now. Okay. Now we can take that lowest value and now compare it with all of the questions. We have our 3 categories, right? Our 3 columns. Now we can compare it all together. Now we check which Gini impurity is the lowest, right? Because the lowest Gini impurity is what? Filtering it down the most to start with, because that's the most pure leaves there is, right? So this study hours is the lowest, right? And then we have homework, and then we have attend class. So then we set the study hours on the top branch like this. And then now we have to choose homework or classes. Homework or classes. Homework or classes. Okay. So to do this, we just take whichever is lower takes that position. So then using the study hours is true or not, we then check if homework. So we have our filtered data set from study hours is true, right? And then we're now taking out all the other values that are not true for study hours is greater than 8. So that first value is gone, right? Those values are gone. Now we're checking how many pass and fail in that data, okay? And let's say 2 pass and 2 fail, like this, okay? So now they're pure leaps. So then we stop asking questions because we don't need to ask any more questions because we filtered it down to pure leaves. Since this is already pure to begin with in our study hours thing, we don't need to ask another question. There's no need to ask another question because it's already pure. It can't be filtered down anymore. So the goal of this is we keep filtering and doing the same methods until we get the most pure leaves possible. Okay. And of course, if there's no more, questions to ask and it's not pure in the end, then we just do our best guess, right? The model makes its best guess. But this is usually how it goes. And that's how this works. Okay. Anyone have any questions? I want to get started with the programming. So anyone have any quick questions to clarify? And if you're confused about this topic, just watch yesterday's recording. I explained it much more in detail. This is just a quick overview for those who haven't joined yesterday's session. But I would suggest if you have any more doubts, I would watch the recording from yesterday. But if you have any questions now, I'm happy to answer them because you need to understand how it works when we code. Anyone have any questions? No? Really? Okay. Sounds good. All right, let's get to coding. So let me explain. Okay, okay. All right. Let me just run this. Let's see if it works. I wrote it today. I haven't ran it yet. Let me see if it works. Okay, good, it worked. Okay, cool. So can everyone see my code screen? Anyone having any difficulty seeing that? No? Good. All right. So we're using the same libraries as before. Here we have pandas, right? Pandas, all it's doing is creating our data frame. So I just created some random variables here, and then I'm just creating it here, right? So pandas in this case is just creating my data frame based on this data. That's all it's doing, not anything too complex. It's just creating our CSV file, I guess. And then here we're just getting from sklearn, we're getting the actual decision tree classifier, and we're getting this plot tree. So the plot tree, it's not necessary. I just did it for demonstration purposes. So you can completely ignore this part. It's just used so you can see it. And then matplotlib, that you're always going to need this for, graphs, exporting graphs and different things like that. You need it. So for creating graph purposes. So these are the libraries we're going to be using. So using pandas, we created this data, we set the data, created our data frame, and created it here. We're feeding in this data. So this data is being fed in and it's creating a data frame. And then like before, using the data frame, we're selecting our features or independent variables. In this case, feature 1, feature 2, okay? And we have our label as our dependent variable, okay? And if you notice, right, like always, we always do double brackets for independent variables or x variables, right? And single bracket for dependent variables, okay? And then here we create our decision tree classifier. And if you notice something I did, inside of this field here, I'm specifying what type of model. Okay. Why am I doing that? Just for demonstration purposes, because this is what I taught today. I talked about Gini impurity method, right? There's a lot of different methods out there. I could even change this to entropy, and it would run for entropy, right? But we're talking about Gini impurity, so we're using Gini impurity method. Okay, so now I can also just take this out and I'll run its own algorithm, but for this demonstration, Gini impurity. Okay. So then we're doing the fit. And what does fit do? Who wants to tell me what fit does? We used it for everything we have done so far. What does fit do? 5 points are on the line.
It runs the optimization algorithm to find the W and B.
Okay, good. Yeah, that's part of fit. Yeah, good job. Thank you for speaking up. Yeah, so fit trains the model, right? So training the model is what? It's doing your loss function, right? Doing your optimization function, right? Getting those two variables, and then it's using it for your testing phase. So good. We're training the models based on our input data. So our data frame is being fed here, our feature 1 on the X side, feature 2 on the X side, and label for the Y side. Okay, so far so clear? And here, all we're doing, we're just plotting the figure of our model on what it trained, and then finally we're plotting the tree with our decision tree. So this is just our fig, not too, nothing too crazy. Yeah, okay. So this is how our values finally look like, right? We're seeing our Gini impurity on each one. Samples 3. And if you notice, it filters it down to pure leaves, right? We got Gini impurity of 0 on both. So we're asking one question, and that question is feature 2, okay? And we're seeing feature 2 is less than or equal to 0.5. All right. Yeah, okay. So that's how it works. I just created another one here using without like anything specific. It's the same data set. And then this one, oh yes, let's get into this one. This one I'm using entropy, but it's all the same concept. The formulas does change a little bit, but it's almost all the same thing. So now, now, you don't really need to understand anything. We're doing the same exact process, but remember last time I created a data frame with numeric values, and this time it's using categorical values. So the math is a little bit easier, since it doesn't have to do all those complex sorting, and then finding each one. So it's a little bit easier with categorical on the model side, but the computer does everything for us. So all you really need to know is make sure you're using this data frame, and we're encoding, right? So we're doing encoding here too. So what is encoding? Right, since these are categorical, right? You have to make sure the computer understands what each one means. So we gotta encode them. So since weather and temperature are categorical, it just transforms them into numeric values. So for example, sunny could be 0, overcast could be 1, and then rainy could be something else, right? So it's doing some encoding, so the computer understands what each one means, because some computer doesn't understand, sunny, overcast. It needs to understand through numeric data. So you're just encoding these variables, and you got to make sure you're encoding them. And then here, df encode, you're encoding weather and temperature, and then you're feeding it into your X data, and then df play, you can just keep it as it is, and then you can finally train your model. Okay. That's all decision trees. So what we're gonna do now is I want everyone to open up their Jupyter Labs and go to GitHub. I think I posted this. See, I'm pretty sure I have posted this. Let's go check. No, okay. I'll post it real quick. Give me 1 second, guys. Yeah. So that way you guys can have the code and work with it. Jonesburg. Okay, perfect. Okay, I'm adding in the code right. So test. Yeah. Gonna. Okay, yeah. You guys should have the code now. So everyone go to GitHub. The link is in Discord, or I can send it in chat as well. So do that. And go to day 5. Yeah. And going to day 5, you can just use the last cell code, and you guys can try it out on your side. And if anyone has any questions on how this works, you guys can ask now. But I really strongly suggest finding a database online, through Kaggle, and trying it out on your own. So finding database, and then remember how we always get data. We just do pd.read CSV, and then you can just drag and drop in your data set wherever you have your source directory. And then, for example, my data set's called test.csv. I'll just put that name, make sure you have it in quotations, and now you don't even need this part. Okay, df. You can just directly call this df, and then it would extract, and then make sure you're changing the names of these to whatever columns are your independent variable, and then whatever columns are your dependent variable, and then yeah, and then it would read that, and then you don't have to change anything here, because all this is here is you're creating your model. So for example, we're using linear regression. Make sure you import linear regression here, and then you would just change this code to linear regression, and then you don't need this, right? And then everything else is the same steps as before. Okay, cool. Does that make sense to everyone how we can do this? Yeah. Okay.
Can you say that again? Can you repeat that?
Was
Like
that
like
Sajin, was that you?
instructions? Yeah, that was me.
No,
Can you
I'm just saying, if you guys want to test this out on your own with data sets that you found online, all you have to do is data pd.readcsv, put in the dataset name, make sure you import it, like drag and drop it into your file that you have this code in. So I would drop it here. And then you can delete this, and then you can just rename this to df, and then it would work. And then make sure to rename this to your correct column names, like your correct independent variables, and then dependent variable here, and then it would work. So if you noticed, every model that we created so far has almost the same code, right? We're just changing the imports. So if we want linear regression, we would type in linear regression, and then we would change this code to linear regression, and then we can just delete this inside. Okay, it's almost the same thing, because all models, the basics of this is we have our training, testing, and the type of model we're using. Okay, that's all it is.
Okay.
Anyone have any questions? Yeah, Ritvik, go ahead.
How does the model use the 3 liners of columns for a genie? Because if you look at the example slides from before, you had a table of pass and fail, right? How does that actually work with just a bunch of numbers or letters in 3 things?
Yeah, if you notice, we have pass or fail here too. Value, pass or fail here. In this case, it's looking at the data set, and then it's creating its own questions, right? So it doesn't actually tell you. Wait, does it? No, I don't think so. Yeah, no, it does tell you. Okay, yeah. Okay, yeah. Right here, feature 2 is less than or equal to 0.5. right? It's running that the code, like the algorithm I taught you before on, sorting. Since this is numeric values, it's sorting it out, numerically, and then it's performing the, what's it called, the average of each adjacent value, and then it's doing the same thing, right? It's creating that table of value here, and then in this case the question is feature 2, which is this feature, and it found out that this has the lowest Gini impurity, and it's saying feature 2 is less than or equal to 0.5. Okay, that's our first question, and then it filtered it down in one question. It didn't even have to ask 2 questions. It filtered all of this down in one question. So it reads and understands this data and it creates it. So whenever you create an input, right, you're testing this model. After you create this model, you're testing it. You give it new data, and then it'll tell you. So for example, in feature 1, you say a value of 3. It'll tell you the output of that. Okay. Class no or class yes. It'll tell you if it's in class no or class yes. That's all.
Where does feature 1 get used? Is feature 1 just all training?
No. I think you're misunderstanding it. All this data is used for training. All of it is used for training. So it's
Okay.
doing the same numeric calculations as before for each one of these. Okay, and then it gets the Gini impurity of each individual branch, right? So there's 2 branches, right? Since this is output, there's 2 features. Does Gini impurity, checks which has the lowest Gini impurity, and if these, for example, were not pure, right? This one is not pure. Then it would compare. Okay, since there's only one left, it would just ask another question and create a new branch and then have the output leaves of those. That's how this works. Okay?
The features are kind of like questions.
Yeah. Okay, yeah. If there's no other questions, we can wrap it up today a little bit earlier. We have like 4 minutes left. So anyone has any questions, please ask them, or else thank you everyone for joining today. It was nice to see you guys. So thank you. Yeah, no problem. Thank you for joining. Yeah. Yes, go ahead, Padma, ask your question.
Basically, like, I'm joining for the first time because I was like busy for the last few days. Um, but you like posted all the recordings, right? Like,
Yeah, it's posted on Discord, and every email I sent, I'm pretty sure I attached the YouTube link for the recordings. So if you just go check your Discord on the right under the workshop channel, there's a channel called Recorded Workshop Sessions or something like that. It says something recorded, but it's all the days recordings are on there.
okay,
Yeah. Did that answer your question?
yeah. Bye then.
Do you see it?
Yeah, I see you.
Okay. All right. Thank you for joining.
Yeah.
Okay. All right. Bye, everyone.